Hello everyone, today in this video we are going to solve some question on application of triangle law. So after this video you should be able to apply triangle law to calculate relative velocity. So this is the triangle law. If two vectors represent the two sides of a triangle, then the resultant of these two vectors will be represented by the third side of the triangle. And you have to see the tip and toe of these two vectors should come together, and the magnitude of resultant vector will be given by this expression, and the direction of the resultant will be given by this expression. And in this expression, to find the angle out here and out here, we'll write the vector which is opposite to the angle. So out here you can see B is the vector which is opposite to the angle, and out here we write the vector which is opposite to the resultant vector. So out here you can see this A is opposite to the resultant vector. So out here we'll write A, and at these two point we'll write this vector. So using these two expressions we can find the magnitude and direction of the resultant vector. And suppose if I want to find A minus B, then this is A and this is vector B, but I need negative B, so I'll draw another vector in the opposite direction of B. So this will be our minus B. So resultant of these two will give us A minus B. And relative velocity means velocity of an object for other object. Suppose VA and VB are the velocities of these two objects with respect to ground. So then the relative velocity of B with respect to A will be given by VB minus VA, and we denote this by VBA. Similarly, relative velocity of A with respect to B will be given by VAB, and we write VA minus VB. So whatever sequence we are writing A and B, here we'll write VA and VB in that sequence only. And this is the general formula. So relative velocity of 1 with respect to 2 will be given by V12, which is V1 minus V2. And now we'll solve the question on triangle law and relative velocity. So the question is like this: rain is falling vertically with a velocity of 25 meter per second. A woman rides a bicycle with the speed of 10 meter per second in the north to south direction. What is the apparent speed of the rain? In which direction she should hold the umbrella to save herself from the rain? In this question, velocity of rain is given, which is vertically downward, and woman is going from north to south with the speed of 10 meter per second. So this is a vertical, and this is north and south. So we are not writing east, west, north, south, so we can write north, south anywhere we like. So the rain is going vertically downward, and woman is going from north to south. So angle between these two vectors is 90 degree. So we have to find the apparent speed of the rain, means velocity of rain for woman, or we can write the speed of rain with respect to woman. So we have to find VRW, and we have to find the beta, angle between resultant and one of the vector, or the angle in which she should hold the umbrella. This is the formula for velocity of rain with respect to woman, that is VR minus VW. So now we need minus VW, but we don't have minus VW out here, so we'll reverse this vector. So out here we'll get minus VW. So now VRW, velocity of rain with respect to woman, is the resultant of VR and minus VW. So out here we cannot use triangle law because tip and toe is not coming together. So I'll shift this vector down. So now I can use the triangle law. So two vectors are representing the two sides of the triangle. So the third side will give the resultant vector, that is velocity of rain with respect to woman. And the angle between two vector is 90 degree. As the rain is falling in this direction, she should hold the umbrella in this direction only. So we have to find beta. So we know the resultant vector is given by this. So now velocity of rain with respect to human will be given by this expression. So out here theta is 90 degree and VR and VW are given, so I can put the value, and cos 90 is 0, so I'm left with this 2. So if you solve this, you'll get 26.92 meter per second. So now this is the velocity of the rain for human. So human will see the rain falling with this speed and in this direction. Now we have to find the beta, and this is the formula to find the direction of resultant vector. So out here A is the vector which is opposite to the angle. So out here opposite to the angle is VW. So we have shifted VW out here, and out here we'll write V rain. So if you put the values, sin 90 is 1, cos 90 is 0. So after putting the value, you'll get beta is equal to tan inverse 2 by 5. So she should hold the umbrella tan inverse 2 by 5 degree towards the south with the vertical. So she should hold the umbrella in this angle, so towards the south, and this is the angle. So this is the next question. A driver going east in a car with the velocity 40 km per hour and a bus moves with the velocity of 80 km per hour in the direction 30 degree east of north. Calculate the relative velocity of the bus with respect to the car. So these are the 4 directions, and the car is going towards the east with 40 km per hour. Bus is going with 80 km per hour in the direction 30 degree east of north. So from north I'll draw 30 degree, and this is the velocity of bus. So bus is going in this direction. So I have to find velocity of bus with respect to car. So these are the things which are given. So I have to find VBC. So for VBC I can write VBC is equal to VB minus VC. Now I have to use triangle law out here. So for that I need minus VC. So in order to get minus VC, I'll reverse this vector. So this is minus VC. Now the resultant of this and this will be the velocity of bus with respect to car, and the angle between these two vector is this 30 degree plus this 90 degree, so 120 degree. Now I cannot use triangle law out here because tip and toe is not coming together, so I'll shift this vector out here. So now I can use the triangle law. If two vectors represent the two sides of the triangle, then the resultant will be represented by third sides, and this is the angle made by the resultant with VC. And to find the magnitude of the resultant vector, we make use of this formula. So I'll put the values now. So one of the vector is VV and another vector is VC. So I'll put the values 40 and 80, and cos 120 degrees minus half. So VBC will come as 4800. So now I'll factorize this, and I'll get VBC to be 40 root 3 meter per second. So velocity of bus with respect to car is 40 root 3. Now I have to find the direction. So to find the direction, I make use of this expression. So A is the vector opposite to the angle, so this is VB, and for B I'll write VC. So if I put the value, sin 120 degrees root 3 by 2, cos 120 degrees minus half. So if you put the value, you will get beta to be tan inverse 40 root 3 by 0. So this is something by 0 is infinity. So tan inverse infinity means 90 degree, because tan 90 is infinity. So beta will be 90 degree. So the bus will appear to move towards the north, because if you draw 90 degree from here, it will go towards the north. So bus will appear to move towards the north, and the speed of the bus is 40 root 3 meter per second for the car. So this is the same question done in one page, you can pause and copy. And similarly you can try this question. Now next question, to a person moving east with a velocity of 4.8 km per hour, rain appears to fall vertically downward with the speed of 6.4 km per hour. Find the actual speed and the direction of the rain. So in this question, relative velocity is given, you have to find the actual velocity. So out here velocity of man is given, velocity of rain with respect to man is also given. You have to find the velocity of rain and the angle made by the velocity of the rain. So this is the vertical and we have east and west direction. So man is going towards the east and the rain is appear to fall vertically downward. So for man, rain is appear to fall vertically downward. That means velocity of rain with respect to man is vertically downward. We have to find VR. So we know VRM is VR minus VM. So we have to find VR. So if you rearrange the equation, you will get VR is equal to VRM plus VM. So VR is the resultant of VRM and VM. So resultant of these two will give us V rain. But right now I cannot use triangle law because tip and toe are not coming together. In order to make tip toe together, I'll shift this vector down out here. So now I can use the triangle law. So this will be our VR. So these are the two sides of the triangle. So third side will give the resultant. So this is the VR, velocity of rain, and angle between VM and VRM is 90 degree. And we have to find the direction of VR, that is angle beta. So I'll give the names for this triangle. So now we know this is the formula for resultant. So if you put the values VRM and VM and cos theta, that is 90 degrees 0. So I'll just put the values VRM square and VM square. And if you solve this, you'll get VR to be root over 64. That is VR is 8 meter per second. Now we have to find the direction. So now if we get the right angle triangle, we don't need to use the formula that we have used in previous case, or you can try that formula also, you will get the same result. So out here in this triangle, tan beta is PR by OP. So if you put the values, you will get beta to be tan inverse 4.8 by 6.4. So the rain falls at the angle of tan inverse 4.8 by 6.4 degree towards the east. So because this angle is towards the east, so this much angle towards the east. So this is the final answer. Now this is the similar question, you can try this question. So answers are given out here. So this is the end of the video. Please don't forget to like, subscribe and comment. If you need any help in any of the topic, you can WhatsApp me the topic. I'll try to help you out. So thank you.